Hello, can you hear my voice?
Hello, yes, we can.
Yeah, how are you guys doing today?
I'm good. How are
Fine, thank you. All right. I couldn't make it to the campus today. So I decided to have this virtually. So just give me 1 minute. Let me pull out your class. Your class is right here. Oh, yeah, right there. Great. All right. Two more people waiting again. Now we have this is you right here. For this week, we're going to have, can see my announcement for the week right here. Yeah, week 7. We are now in week 7. We're moving. We are getting there step by step. So the readings, we are now in chapter 5. Can start reading chapter 5. And for the assignment, I'm gonna have your classwork ready after we finish today. Then homework 6. Now homework 6, I might extend it to next week. Yeah, I might extend it to next week. I don't know yet. No, we'll figure that out later. Then complete Excel assignment 4 by Sunday, of course, October 6th. And that's it for the assignment for the week. Okay. So let's begin. We start the week with this topic, probability distributions. Can you see the screen, guys? Can you see the screen?
Yeah.
Clearly? Okay, good. Excellent. Excellent. So let's start with the basic concept. We start with random variable. And when we say random variable, we are referring to a variable that has values which are determined by chance, called a random variable. For example, if a dice is tossed, the outcome can be 1 showing up, 2 showing up, 3 showing up, 4 showing up, all the way to 6. So any of them can show up. So it's random. And that gives us a good example of a random variable. How about this? Number of siblings a Morgan State students can be 1, 2, 3. For us, it's a random variable. For the student is not, but for us who knows her or him, is a good example of a random variable. Yep. Now, how about this? The time a bus arrives at the bus stop. It can be 5 minutes early or 5 minutes late, so 10 minutes early, 10 minutes late. But it's a random variable. Now, there's one that we call discrete random variable. Discrete random variable. The discrete random variable is a random variable in which it has a finite number of values that can be counted. That's why we call it discrete. Can be counted. See? That can be counted. So we call it discrete random variable. Like, how many people are jogging at Patterson Park in the evening? It can be 1 person, it can be 2 people, 3 people. So you can count them. So that's why you call them discrete random variables. How about this? The number of eggs that a hen lays in 1 week is also a discrete random variable because it can be counted. So how about this? Number of calls received after a TV commercial is also a random variable. You can say 1 call, 2 calls, 3 calls. You cannot say 1.5 calls. And for the people jogging at the Patterson Park, you can't say 2.5 people or 10.5 people. No, it's 1 person, 2 people, 3 people. Now, there's one we call continuous random variable. This type of random variable cannot be counted, but can be measured. they can be measured. As you can see, for example, height, temperature, voltage. These are the continuous random variables since they can be measured. Yeah. Now, today we focus more on the discrete random variables. But this week, we focus more on the discrete random variables. Now, a discrete random variable consists of values. A random variable can, we focus on the discrete probability distributions. Discrete probability distributions. So, a discrete probability distribution is a type of probability distribution which can, it consists of values that a random variable can have plus their corresponding probabilities of those values. So there are several types, but for this class, we're focusing only on binomial. You can see the examples, have binomial distribution, a Poisson distribution. We focus only on the binomial distribution. Okay. Now we have a continuous probability distributions. And that one, we'll do that probably when we finish with the discrete type. We can then go to the continuous type. For the continuous probability distribution, we focus only on the normal distribution. Normal distribution. Yeah. Okay, so now let us do some background. I mean, there are several types. We have the normal distribution, we have the uniform distribution, but we focus only on normal distribution for this class. So, but before we do that, let's look at some backgrounds. Let's set the stage by giving you more background information about probability distributions. Now, this question says, construct a probability distribution for rolling a single dice. Of course, you know how a dice looks like. So to do that, to answer this question, you remember that a probability distribution simply means the values a random variable can take and the corresponding probabilities of those values. So having that in mind, when this question says construct a probability distribution for rolling of a single dice, it means all the outcome in a dice plus their corresponding probabilities. So to make that means we have to make a table that looks like this one. I'm gonna make it 16. Okay. Somebody entered. So you make a table like that one, and then you can now okay. See the outcomes for a dice can be 3, can be 6, can be 5, it can be 1 showing up, 2 showing up, 3, 4, 5. So these are the outcome. Now the corresponding probability for dice is for each of them is 1 out of 6 chances. This one is also 1 out of 6 chances. For 3 showing up, the probability of 3 showing up when you toss the dice is also 1 out of 6 chances. For all of them is 1 out of 6 chances. For each outcome, the dice, 1 out of 6. Okay, 1 out of 6. So now, so that we have that these are all the outcomes, and we are done. Because it says construct a probability distribution for rolling a single dice. So once you have this, have the outcomes and then their corresponding probabilities, you are done. Any question on this? Any question, guys? All right, good, excellent. No question, good. Now let us look at another thing we need to do here, which is the look at this question. It says during the summer months, BMZ recorded. Let me put this. Recorded. BMZ is a rental agency, and he recorded. He keeps track of number of chainsaws it rents each day during a period of 90 days. Number of chainsaws BMZ rented per day is represented by the variable X. The result are shown here. You can see the how many days they didn't rent a saw. 45 days. One saw rented out in 30 days, and so on and so forth. Question says compute PX for X for each X. I mean, say compute the probability distribution for all this outcome here. And it says construct a probability distribution and graph the data. Okay. So to do this, we can now make a table of this. We can make more tables like this. So I'm gonna copy this here, and then send it, put it right here, solution, and that solution we can put it right here. So I'm gonna expand it. So make sure you expand this. When I put this here, I'm gonna add this one column here. Okay, good, excellent. So I'm gonna construct it. So now we have into answering two questions to construct PX for each X, and then construct a probability distribution and graph the data. Good. So let's calculate the PX for each of them. PS, that means the probability of X. So first of all, let's get the total of this. 45 plus 30. Let me write it down so we can get the total. We got 45 plus 30 plus 15. So I'm gonna get it from the calculator. We have where is my calculator? Okay, let me see. I got my decimals. Okay, good. So we have 45. Okay, plus I'll move this down a little bit. Let's see. Plus 30 plus 15. Give me 90. 90. So I'm gonna go back to that place and put 90 here. 90. Okay. 90. That's the total we have for it. It's 90. Okay. So 90 will be total. Now let's find the PX, because the question says compute PX for each X. So we're going to find the PX for each X now. So the probability, start with the first one, which is the probability of 0. P0, which is the, I'm gonna make it 18 because it's too small here. So P0, that means the probability of 0 is how many are zeros here? 45 days are the days that they did not rent any chainsaw, which is 45 out of 90. Yeah. On the calculator, we can get that probabilities. 45 divided by 90, it was 0.50. Okay. 0.50. Then we need to find the probability of 1 as well. P of 1. Okay. Equal 30 divided by 90. 30 divided by 90. That will give us the probability of 1. That's one chainsaw was rented out. So we can just come here and put 30 right here. 30. It was 0.33 rounded. 0.33 rounded. Okay, we have 0.33. Next one will be to find the probability of 2, okay, of 2 will be equal to 15 over 90. 15, yeah, 15 divided by 90. Okay, got 15. Okay, 15 by 90. Give me 0.17 rounded. 0.17 rounded. 0.17. So that means we have each of these probabilities. So we have P of 0, because it says compute the PX for each S. We have them here. Then part B says construct a probability distribution and grab the data. So that means these are probabilities right here. For 0, we have 0.5. I'm going to put it here. 0.5. For 1, P of 1 is 0.33. 0.33. And for 2, we have the P of 2 as 0.17. So now we can now remove this here. We can now have our the given P or probability distribution. Let me have everything here. Let me just paste it below this, so we can put only the part that is the probability distribution. So I'm going to remove this one now, so I have it here. I'm going to remove this part. So this is the required probability distribution is shown below. So you can see the outcome X and their corresponding probabilities PX, and that we answer the question. So but we're not done yet, because it says construct a probability distribution and graph the data. So you can graph this data. Yeah, you can graph it. So let's graph it. Okay, I'm gonna put the graph here. We got outcome. It says is not okay, we have outcomes includes outcome here include a number of the number of chainsaws rented. It rents. So we have it here. With me. Number of chainsaws. Yeah, rented. So I'm going to make this to be 18. Then we have the PX here. PX, the probability of X, PX. Okay, I'm gonna make it closer a little bit. I'll make it 18 again. So we got here we have, okay, 0 chainsaw rented, 1 chainsaw rented, 2 chainsaws rented. Okay. Now I'm gonna make it probably 16. Okay. Then we have their individual probabilities. They start from 0.7 to 0.50. So we have probably we're gonna have I'll call it go up a little bit. I'll call it 0.1. Okay. 0.2, 0.3. So I'm gonna make all of this 16. Correct, okay? So we're gonna have this is a PX. So we're gonna put the lines now. Show you. See this. We're gonna put the lines. I'm gonna build a line here. No, not this one. I don't need this. I'll put the lines. This line I need is right here. Okay, it's the line. And then see the x-axis. And this is the y-axis. So I can move it a little bit. I'll make it to be legible. Okay. Now for one, okay, make it down a little bit. So we have this, make this one also go up a little bit. Now we can put this in. This one said for 0 is 0.5. So we need to go up a little bit more. 0.5, 0.4, to go up a little bit more. 0.5. I'm gonna make it 16 like the other ones. Okay, I'm gonna make it power. So that means I can extend it to 0.5. Now we have it. The chart. Let me just now make we can now make the chart. Okay, everybody's in. Excellent. Let me make the chart. Say for 0 is 0.5. So I'm gonna draw 0 right here. Let me draw 0.5. Okay, 0.5 is right here. I can all the way to 0.5. Okay. Now for 1 is 0.33. Look at 0.3 right here. So 0.33 should be around this neighborhood. Okay. So for 1, 0.3. Okay. 3.33 should be around here. Okay. All right, Pompey. Okay. Now, for the other one, which is 2, which is 0.17. This is 0.1 right here. 0.17 should be very close to 2. So for 2, we're gonna have 0.17. All right, so very close to 2 right here. This is close to 2. Not exactly 2, but close. Okay, we can make it right. So these are the graph right here, like a histogram. Okay. Okay, this one a little bit closer to this. That's the graph right there. So I can show you the trend. On this graph, you can see the trend. Okay. Now, for that question we answered, we got the probabilities, calculated them, got the probability distribution table, then got a graph. Now, any question on this? Any question? Good. Excellent. Now, having given you this background, we can now take a quick look at the 2 requirements for a probability distribution. 2 main requirements. Okay. 2 main requirements that when you see a distribution that have this requirement, then it means that it is a probability distribution. Okay. First requirement that the sum of the probabilities of all the events in the sample space must equal 1. The sum of all the probabilities, of all the events in the sample space must equal 1. What does that mean? Now, we look at what we have done so far. Starting from this first one, say if you add this symbol means sum of. So sum of px, sum of all the probabilities would come equals 1/6. I'm gonna make it 18. 18 should be better. 1/6 plus 1/6 plus 1/6 plus 1/6. Okay, plus 1/6. How many do we have here? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So we have one more. Plus 1/6 will be equal to 6/6 plus 6, which give us 1. That means the total here will be 1.0. See? That's what it's saying. And for the second one we did, this one here, if you add all the probabilities here, that will give us equals 0.50. Okay. I'll make this 18 plus 0.33 plus 0.17 will be let's write this down so we can add it on the calculator. I got 0.50 plus 0.33 plus 0.17. Okay, we can get it from the calculator. We got 0.50 plus 0.33 plus 0.17 give me 1. So that means if the answer is not, total is not 1, that means that distribution is not a probability distribution. That's what this formula, this features, this characteristic says. 2 requirements. The second requirement is this: the probability of each event in a sample space must be between or equal to 1, which means that the probability of that a probability can never be greater than 1, and it can never be negative. It cannot be negative and it cannot be greater than 1. So let's see example here. It says, I gotta move this. It says here, determine whether each distribution is a probability distribution. Let's look at this one, first one. So remember the first feature, that the sum of the probabilities of all the events must equal 1. So let's see if this represents a true probability distribution. First of all, we'll just try the sum, right? Sum, we're gonna be using it using 18. So sum will be this is X, this is the PS. So we add all the probabilities. 1/5 plus 1/5 plus 1/5 plus 1/5. How many do we have? We have 1, 2, 3, 4, 5. So 1, 2, 3. That's one more. Plus 1/5 equals 5/5. That gives us 1. So the answer is yes, because the sum of the probabilities equals 1. Yes, because the sum of the probabilities equals 1. Okay. Any question on this one? Any query? Yeah, no question. Good. Now let's try the second one then. Remember the question says, determine whether each distribution is a probability distribution. We have found that this one is, it is, and I have shown you the reason. Let's look at the second one, which is this one here. I want to bring it to next page so we can have enough room. Says, is this a probability distribution The answer is this one. You don't even have to do anything because remember the second requirement say that a probability cannot be a negative number or a number that is greater than 1. And we have a negative number here already, negative 1.2. So you don't even have to do any work. Just say no, because one of the probabilities, which is px has a negative value. Okay, that answers that. Now look at the third one. It says, is this a probability distribution? We don't know. We find out by doing the sum, making this equal to 18. So we're gonna have equals, I want to sum add all the px's. We got 1/4 plus 1/8 plus 1/16 plus 9/16. Let's go and check this. See if it is, if you add to 1. If it doesn't, then it's not a probability distribution. We got 1/4 plus 1/8 plus 1/16 plus 9/16. Go and test this in a calculator. You know, that'll give us. So you got 1/4, 1/4. Okay, plus 1/8 plus 1/16. Okay, plus 9/16. So you give me 1.0. 1.0. So the answer is, again, yes. Because the sum of the probabilities equals 1. Okay. So now we try the next one, which is this one here. Is it a probability distribution? We'll see. Let's check. Like this 18. Again, the sum of the probabilities now becomes 0.5 plus 0.3 plus 0.4. Let's check it. Oh, excuse me. Let me write them down before we check it. I got 0.5 plus 0.3 plus 0.4. So I got 0.5 plus 0.3 plus 0.4. That means 1.2. I mean, it is not. For it to be a probability distribution, it must add to 1. So answer is 1.2. No. Because the sum of the probabilities is greater than 1. Okay. Now, any question to all of this? Any query? Any question? So no question. Excellent. Excellent. So we're gonna try another example. Okay. Okay, let's see. This one. It says determine whether determine the required missing determine the required or missing value of B to make the distribution a discrete probability distribution. Now, if you look at the outcomes, you have the outcomes and you can see their corresponding probabilities. Now, one of them is B. They didn't have the answer there. So that's the one they want us to find. To do that, now you already know that one of the requirements is that the sum of the probabilities of all the events in the sample space must equal 1. So you know that already in the back of your mind. Now, with that, you can now go back and say, okay, that means to get this, you do 1 minus all these probabilities. So you have 1 minus 0.41 plus 0.02 plus 0.35, and that will give you the answer you're looking for. Give you the answer you're looking for. So we have let me write this down. B equals 1 minus 2.41 plus 0.02 plus 0.35. And that will give you the answer you're looking for. Let's go and get it from the calculator. Okay. 1 minus 0.41 plus 0.02 plus 0.35. Okay, it's 2.22. 2.22. So you got B 0.22. That's what we got, I believe. Yeah, 0.22. Okay. Now, having said that and having gotten the answer, we can now look at the mean, variance, and standard deviation of a probability distribution. Now, remember, we did the mean, variance, and standard deviation, but we did that for a frequency distribution. Now, we're going to do it for a probability distribution. Mean is sum of x times px. And variance is sum of x squared times px minus the mean squared. Then standard deviation will be always, as always, the square root of variance. Okay? Let us try this for this question. It says, Davis Williams is the president. In 1 minute. Okay? Davis Williams is the president of the Middle River Community Bank. Mr. Williams feels that each savings account customer has, on average, 3 credit cards. The following distribution represents the number of credit cards each people own. See the number of credit card X and their corresponding probabilities. 0 credit card 0.18, 1 credit card 0.44, and so on. It says, find the mean, variance, and standard deviation. Now, is Mr. Williams correct in his claim? We'll see. To do that, to make a table, as a matter of fact, there are 2 ways of doing it. But like I said, stick to the one we're using in class so that you don't have any problem. I'm going to use a shortcut method by making a table like this. Okay? So put all the numbers, see the x and px right here. So you see x times px means this times that. Okay? So 0 times 0.18 is 0.18. 0.00 I mean to say. Give me 1 minute. Let us make this faster. Just 1 minute. Excuse me. Yeah. So we have this. Can put all this in the calculator to get our result. The next thing is 1 times 0.44 is 0.44. 2 times 0.27. So we go like that. We continue like that until we get the rest of them. Let me get a calculator as a matter of fact. My pen. We got 2 times 0.27. 2 times 0.27. Got 2 times 0.27. 0.54. 0.54. So I've had this done before. I click we can finish this on time. Just 1 minute. Okay. All right. Then I have 3 times 0.08. You can always verify this. 0.24. 4 times 0.03 give us 0.12. Yeah, I did it on paper already, so I just put it in, but you can verify that the multiplication. Next one is to get the x squared. I mean, you could have squared this. 0 square is 0. 1 square is 1. 2 square is 4. 3 square means 3 times 3, 9. Then 4 square means 4 times 4, 16. Now, next thing we need to get is this one, which is x squared times px. Make sure I've seen this. X squared times px. So we got okay, have x squared times px means let me show you what it means. It means x squared here times px. That's what it means. That means now 0 times 0.18 is 0.18. 1 times 0.44 is 0.44. 4 times 0.27. For that one, I got 1.08. Can verify this. 9 times 0.08. I got 0.4. 9 times 0.08. I got 0.70. I got 16 times 0.03. I got 2.48. Okay. But sorry, the first one is 0 times 0.18 is 0.00. Because 0 multiply a real number is 0. So this is 0.00, 0.44, 1.08, this one is 72. 9 times 0.08 is 0.72. Then this one is 0.48. So you add all this, you're gonna get 2.72. You can verify it with your calculator. You add all these numbers here. Okay. Then you add this one. You're gonna get 1.34. Okay. So remember the question says, find the mean, variance, and standard deviation. Okay. The mean is sum of x times px. This is x times px right here. Give me 1 minute. This is x times x, and this is the sum. So the mean is 1.34. Okay. 1.34, that means approximately 1 credit card. Now for the variance, we need this formula here. Sum of x squared times px minus mean squared. Now sum of x squared times px, we have it right here. And the sum is 2.72, 2.72 minus mean. Now mean is 1.34. 1.34, and they say to square it. Equal. So we're gonna square it. Okay. So that means that's what we have here. Okay, good. To square it. So we're gonna write this down. 2.72 minus 1.34 squared. Okay, they're gonna give us. So we got 2.72 minus 1.34 squared. Give me 0.92 rounded 0.92. Got 0.92. Then the standard deviation, of course, is going to be square root of that. See? So I'm going to get it from the other workbook. So have inside this formula right here. Standard deviation. I'm going to make it to be 18. Okay, so you can see it clearly. Equals square root of variance. Okay. And our variance, as you know from our calculation, is 0.92. Okay. 0.92 from our calculations. Make sure I have it properly in the calculator. Yeah, 2.72. I want to, okay, 0.92. So variance be our variance is 0.92. So put it on the calculator. Okay, which give us this 0.9244 anyway. Okay, so we're gonna put this right here. Square root of 0.92. Okay, square root of that. So 0.72 to have square root of 0.92. 0.96. 0.96. Okay. 0.96. 0.96. So that becomes our standard deviation. So I'm gonna put it right here. Any question to this one? Any question? Hello, guys. Any question for to this?
I don't have any questions.
All right, guys. So in that case, I will see you guys on Thursday. Okay. I have your names already, so
Okay, Professor. See you Thursday.
you on Thursday. You have a nice day, you guys.
Thank you, you too.
Have a good day.
You said you already took attendance?
Yeah, man, I was taking it as you guys are logging in. What's your name?
Oh, okay. You said what?
What's your name?
Abigail Yaboa.
Say it again.
Abigail Yaboa.
Yeah, I have your name.
Okay.
Mhm.
Do you have Olivia Hogan?
Yeah, I have Hogan. I was taking it as you guys were logging in.
Do you got Ace Lockett?
Yep. So as you're logging, I think. So see you guys Thursday, okay?
Have a nice week. Or
Have a nice day.
You too, guys.